Welcome to another tutorial. In this tutorial, we'll be looking at the rational root theorem and be using it to find zeros of a polynomial. An example I've been given here: find the zeros of x cubed minus 4x squared plus x plus 6. According to the rational root theorem, the root of this polynomial can be expressed from the list of factors of the constant, which is always represented as a sub 0, divided by the list of factors of the leading coefficient, which is always represented as a sub n. Here the leading coefficient is 1. Don't forget that any variable standing alone or independently always have a coefficient of 1. So all we need to do is look for the list of factors of 6 and divide all those factors by the list of factors of 1. The possible factors of 6 could be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And the possible factors of 1 are plus or minus 1. There is no other factor after that. Then we just need to express each of these factors in this term. So let's express them. The factors are plus or minus to bracket 1, 2, 3, and 6. Everything divided by the factors of a sub n, which is just 1. We can close the bracket. We can go further to express these factors independently by, that is, plus or minus into bracket 1 over 1, comma 2 over 1, comma 3 over 1, comma 6 over 1. We close the bracket. The same thing will give us plus or minus 1, 2 over 1 is same thing as 2, 3 over 1 is same thing as 3, 6 over 1 is same thing as 6. So what we've just done here is we have gotten the list of the possible roots. The roots refer to the zeros of the polynomial. So the zeros of this polynomial must be one of these numbers here, which was gotten from the factors of the constant term a sub 0 and the factors of the leading coefficient a sub n. So let's put each of these values into the polynomial and check which of them will give us 0. Any one that gives us 0 is the root to the polynomial. Let us start with plus or minus 1. Putting plus or minus 1 in x cubed minus 4x squared plus x plus 6. Where we see x, let's see plus 1 first. Wherever we see x, let us put plus 1. So x cubed becomes 1 cubed minus 4x squared becomes minus 4, 1 squared, plus x becomes plus 1 plus 6. 1 cube is the same thing as 1. As 1 raised to the power any number will give us 1, minus 4 times 1 gives us 4. Remember the squared here is still going to give us the same answer, plus 1 again, plus 6. So 1 minus 4 is minus 3, plus 1 plus 6. This is not equal to 0. So positive 1 is not a factor of the equation. Now that we've seen that positive 1 is not a factor of the equation, let us use negative 1. So putting x to be negative 1 in x cubed minus 4x squared plus x plus 6. Wherever we see x now we put minus 1. X could become minus 1 cubed minus 4. X is here minus 1 squared plus x is here minus 1 plus no x here, so we just write down the 6. Minus 1 cubed is same thing as minus 1 times itself in 3 places. Minus 1 times minus 1 is plus 1 times another minus 1 is minus 1. Minus 1 squared is minus 1 times minus 1, that is plus 1, times minus 4 is minus 4. Plus times minus is minus 1. We have plus 6. Minus 1 minus 4 is minus 5. Minus 1 again is minus 6. So we have minus 6 plus 6. This is equal to 0. So in other words, negative 1 is a root of this polynomial. So x is equal to minus 1 is a root, and x plus 1 is a factor of the polynomial. So let's continue testing for the possible roots. Now we're going to use plus or minus 2. Let's start with plus 2 first. So putting plus 2 in the question, wherever we see x, let's put plus 2. The first thing is x cubed, so it will become 2 cubed minus 4x squared becomes minus 4, then we have 2 here, we square it, plus x becomes plus 2 plus 6. 2 cube is same thing as 2 times 7 in 3 places, that is 8 minus 2 squared is 2 times 2, which is 4. 4 times 4 is 16, plus 2 plus 6. Let us see, 8 plus 2 is 10, plus 6 is 16. Then we have 16 minus the radius 16 here. Then we have 16 minus 16 to be 0. And again, positive 2 is a root of the expression. So x is equal to 2 is a root, and x minus 2 is a factor. Now we've gotten two factors and two roots. We are left with the last factor and the last root. So let's keep checking. Let's try negative 2. If it is also a root of this polynomial, we have 2 cubed, minus 2 cubed minus 4 minus 2 squared plus minus 2 plus 6. Here we have minus 2 times itself in 3 places. 2 times minus 2 is positive 4 times minus 2 again is minus 8. Then we have minus 2 times minus 2 here to give us positive 4. Positive 4 times minus 4 gives us minus 16. Minus times minus gives us minus 2 plus 6. So we can see minus 8 minus 16 is equal to minus 24. Minus 2, we have minus 26 plus 6. This is not equal to 0. So minus 2 is not a factor. We've gotten two factors so far. We are left with one more factor to go. So let us keep on checking with other values. Recall that the possible roots from start were plus or minus 1, 2, 3, and 6. We've used plus or minus 1, plus or minus 2. We're left with plus or minus 3 and plus or minus 6. Let us also recall the equation x cubed minus 4x squared minus x plus 6. This is plus x plus 6. So let's go ahead to use plus or minus 3 into the equation, starting with positive 3. So wherever we say x, let us put 3. We have x cubed here, so we have 3 cubed minus 4. We have x squared here, we have 3 squared, plus we have x here, so we have 3 plus 6. 3 cubed is 3 times 3 times 3, that is 27, minus 3 squared is 3 times 3, that is 9, times 4, 9 times 4 is 36, plus 3 plus 6. 27 minus 36, we have minus 9 plus 3 plus 6. And we have a total of minus 9 plus 9. This is equal to 0. So in other words, x is equal to 3 is a factor, hence x minus 3 is a factor. So we've gotten x plus 1 as the first factor, x minus 2 the second factor, and x minus 3 to be the last factor. We can check if we were correct. Let's open this bracket. Let's distribute the first bracket over the second one. X into bracket x minus 2 plus 1 into bracket x minus 2. Let us just put the other one aside, x minus 3. X times x is x squared minus x times minus 2 minus 2x plus 1 times x is x plus times minus is minus, 1 times 2 is 2. Then let's collect like terms. So we have x squared minus x minus 2x plus x is minus x minus 2. Then we can use this to multiply the second bracket, x minus 3. X times x squared is x cubed. X times minus x is minus x squared. X times minus 2 is minus 2x. Minus 3 times x squared is minus 3x squared. Minus 3 times minus x is plus 3x. Minus 3 times minus 6 is plus 6. So we continue by collecting like terms. X cubed first. We have minus x squared here, and we have minus 3x squared here. So bring them together, we have minus 4x squared There is minus 2x here and there is plus 2x here. Minus 2 plus 3 is the same thing as plus 1. So we just have plus x here and we have a plus 6. So we can see that we've gotten the original question that we were given, meaning the roots that we got were correct. If we test for other values like plus or minus 6, we can see that this will not be a root or a factor. Let's just try. So put plus 6 first. This is 6 cubed minus 4, 6 squared, plus 6 plus 6. 6 cubed is 6 times 6 times 6. That's equal to 216 minus 36 times 4, 144 plus 6 plus 6. Let's just call this 12. So we can check and see that this is not equal to 0. If we go ahead to use minus 6, we will get minus 216. Here we're going to get minus 6, that is still minus 144, and we'll get minus 6 plus 6. These two cancels out, and we have minus 216 minus 144. This is definitely not equal to 0. So let us also try for minus 3. If we use minus 3 in x cubed minus 4x squared plus x plus 6, putting minus 3 wherever we see x, we have x cubed here because minus 3 cubed minus 4, x is here, minus 3 squared, plus x is here, minus 3, plus 6. Minus 3 cubed is minus 27. This is minus 36, minus 3, plus 6. When we add this up, we will see that this is minus 27 minus 36. This is way higher than positive 6, so it is not equal to 0. In general, the roots to this equation after solving using rational root theorem, we got the first root to be x equal to minus 1. The other root was x equal to 2. And the last root was x equal to 3.